Oh man, I'm bottled up. I can't wait to see it. It represents such a legacy for the program, and we're all excited to see this come together through the launch today.
All right, Alec and I are headed outside to watch the launch, and so we'll send it out to Megan and Mick for the remainder of the count and liftoff, and we'll see you again after the first burn of the second stage. Take it away.
Yeah, here we are at under 10 minutes from launch. Mick and I are going nowhere. We're staying inside here, inside the Mission Director Center, inside Hangar AE at nearby Cape Canaveral Space Force Station, because this is where we continue to monitor the launch team as we march towards that T0 of 5:26 p.m. Eastern Time here on the Florida Space Coast. So right now, Mick, the spacecraft team is beginning to transition the spacecraft to internal power. That's going to take a couple of minutes, right?
Yeah, spacecraft's working their procedures, verifying the health of the spacecraft, getting everything ready. They'll then transition around T-minus 6 minutes, 5 minutes. They'll transition to internal power, finish up that procedure, disconnecting from the ground power at the pad, and getting ready for launch today.
So the last time you guys were with us, the launch team has begun loading super cold liquid oxygen into the Heavy's second stage. That happened at T-minus 18 minutes. The next major fueling milestone, that's expected at T-minus 7 minutes, and that's when SpaceX will chill down the Heavy's 27 engines on the boosters to get ready for engine startup.
Yeah, just like we talked about on the strong back, the team needs to chill down those engines so that we don't provide a thermal shock to all 27 engines. A lot of power there. We heard Daryl and Alec talking about that, getting goesu on its way. That's a very heavy satellite, so right on the cusp of a Falcon 9, but this Falcon Heavy is going to give a lot of performance today. And we're finishing up, Megan, as we're looking at the telemetry here. RP1 on the first stage is coming to fill levels, and LOX on the first stage is almost complete, and second stage LOX is about 50%. So we're proceeding very well with full fuel loading today, and things are going good.
That's awesome. And speaking of weather, we are launching a weather satellite, so we should talk about the launch weather. And we've been watching that in the hours leading up to our launch today. And right now we have great news to report. Launch weather is go for launch. We have found a hole within the some of the storms that are around our area. Launch Weather Officer Brian Cizik again confirming that we have found an opportunity to launch today at 5:26 p.m. Eastern Time.
Yeah, that team worked very quickly. Brian has definitely been very busy this afternoon, but working with Charlie Meyer, the SpaceX launch director, and Dr. Denton Gibson, the NASA launch manager, they moved our window 10 minutes, and they were able to find that sweet spot in the weather today to get things done. And we're hearing that RP1 loading is complete on one of the side boosters, and things are still progressing to completion of loading the Falcon Heavy.
In total, we are going to be loading 2.8 million pounds of propellant into the Falcon Heavy rocket that you see on Launch Pad 39A here at Kennedy Space Center. Again, so far we've heard call-outs that RP1 loading has been completed in the center booster as well as one of the side boosters. We expect to hear a call out that the third and final booster will be completed for fueling of RP1.
Yep, the team's still progressing, looking at the telemetry on the launch vehicle. Things are progressing very well. The data
negative Y, fuel load complete.
And there we hear the negative Y, fuel load complete. So two side boosters and center core are complete with RP1, and they're finishing off liquid oxygen tanking into those three boosters. We should hear that here shortly, that LOX load will be complete as the spacecraft gets ready to go on internal power and continues processing their goesu satellite.
As with the spacecraft, we are also expecting the launch vehicle right now to be transitioning to internal power. Again, we are launching goesu today, the fourth and final weather satellite in the National Oceanic and Atmospheric Administration's GOES-R series of satellites. And once operational, goesu will become GOES-East and provide continuous imagery and atmospheric measurements of the Western Hemisphere. It will monitor weather and environmental conditions in near real time, which is really critical for weather forecasting and severe storm tracking. T-minus 5 minutes and 10 seconds to liftoff.
Falcon Heavy tanks are pressurizing for strong back retract.
There we hear the tanks being pressurized for retract, that strong back or transport erector as we use to transport out. The strong back will begin retracting here shortly, and what you will see at the top of the vehicle is those arms that are around the just below the payload fairing will open up, and once those open
Strong
up,
back lower has started.
the strong back will then tip back slightly a few degrees, getting ready for launch this morning. And then as liftoff occurs, the strong back will fall back a little more to get out of the way as the Falcon Heavy leaves Launch Complex 39A.
Next up, NASA launch manager's go, no go poll, the final check to make sure the NASA team is ready for a launch that's expected in 5 seconds.
NLM, it's the LD on the NLM net with a final status check.
LD, everything's looking good on our end.
Copy that. Thank you.
Thumbs up from NASA, again, confirming that weather, right, was the big watch item, and that is not a constraint to launch right now.
Yep, the team has looked at all the data. Things continue to progress very well. Weather looks really good out there.
And
and
countdown 1.
Dr. Gibson says things are good.
NASA is go for launch.
There we hear the final go for launch from Dr. Denton Gibson on the countdown net, and LOX load on one of the side boosters.
Complete.
There we hear the second call for LOX load complete on the 2 side boosters. LOX load is finishing up in the center core of the first stage booster, and then finishing up as we get down close to T0, the LOX load on second stage. So things progressing very well, Megan.
I do want to mention that Dr. Denton Gibson, this is his first launch as launch manager.
Yes, very happy to have him there. He has been doing very well as he stepped into the NLM position from his mission management position, and very happy to have him on console today as our launch manager for the goesu mission.
Stage 1, LOX load complete.
And there we hear the call out for stage 1. All 3 boosters now have RP1 and LOX on board, so we are just waiting for the remaining LOX to fill into the second stage LOX tank, and Falcon Heavy will be tanked and ready for launch.
And we expect them to finish fueling the second stage with liquid oxygen in about 20 seconds. With this
Stage
call out,
2, LOX load complete.
the Falcon Heavy rocket is completely filled with 2.8 million pounds of propellant.
Team has done very well to get to this point. We are so happy of everything's going, and as you can see on the screen right there, weather outside at Launch Complex 39 looks very good. We're about 1 minute and 50 seconds from launch, and the team's progressing down to get the flight computer ready to take over the launch vehicle. As you see there, Megan, the liquid oxygen being vented out, the plume from the humidity here in Florida. We get to see that looks like it breathes, and we just heard the call out for ground gas closeouts, which is finalizing and venting the ground lines that fill the pressure vessels in the Falcon Heavy, so that they're closing off all the ground connections, turning everything over to internal, getting the Falcon Heavy ready for liftoff.
And in a few seconds, we will arm the flight termination system, and Falcon will be in startup.
Falcon Heavy is in startup.
And that means the Falcon Heavy's flight computer is now in control and will guide the rocket through the last seconds before liftoff.
SpaceX launch director, go for launch.
All systems are go to send NOAA's goesu satellite into space to keep a watchful eye over the Western Hemisphere, helping scientists and meteorologists to issue timely warnings and forecasts.
T-minus 30 seconds.
This will be NASA's Launch Services Program's 16th mission for NOAA.
a great partnership over the years we've had. Looking forward to this launch.
15 seconds.
And here we go. 10,
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Go, go, you.
Liftoff of goesu, NOAA's newest weather satellite, to monitor the Earth and Sun in high definition.
Hear that all pressures engines look nominal. Things looking good as you see the Falcon Heavy soaring towards the heavens. All 27 engines powerfully lifting goesu on its trajectory and ascent into space.
A beautiful shot as we
Power and
track
telemetry nominal.
the rocket from the ground here. The rocket is now powering down for max Q. Max Q is the moment of maximum dynamic pressure on the rocket. Max Q expected at 1 minute 7 seconds. The vehicle is now supersonic,
Falcon Heavy is supersonic.
traveling faster than the speed of sound.
Max Q.
There we heard the call for max Q, maximum dynamic pressure on the Falcon Heavy. Vehicle still performs very well. All the data looks nominal.
A great shot from on board the rocket, looking down on the Earth that it is leaving. And all 27 Merlin engines providing 5.1 million pounds of thrust. Coming up at T plus 2 minutes and 28 seconds, the side boosters are going to shut off while the center core will continue on. Wow, what a shot there of, again, all 27 Merlin engines firing off 5.1 million pounds of thrust.
The side booster cutoff will be referred to as BECO. We'll hear that call out. And then when the center core shuts off later in flight, we'll hear that called as main engine cutoff, or MECO. Side boosters are all boosters are performing nominally. Everything's looking good with the 27 Merlin engines.
Side booster separation confirmed.
There we see BECO and side booster.
MVAC chill.
Side booster separation. The MVAC is being chilled down, getting ready for ignition once the center core.
NY boost back startup.
And there we heard the call out for boost back startup.
A lot of things happening here. So again, we have the 2 boosters that are going to be returning to the Cape here, landing at landing zones 1 and 2. These 2 boosters have 3 burns, so we're seeing a boost back burn
All
now.
vehicles are following nominal trajectories.
Essentially, these boosters have flipped back and are returning on a path to the Cape here. There will be 2 more burns, a re-entry burn and then a landing burn. And these are going to provide quite a show for folks that are here on the Space Coast, because you're going to hear those sonic booms, Mick.
Yeah, absolutely. We are looking forward to those sonic booms as the side boosters land at landing zone 1 and 2. We're about 26 seconds away from main engine cutoff and the center core separating. Once the center core separates, we will then have MVAC, which is the Merlin vacuum engine for space, start up and get ready for what we call SES-1. Number 1. Today we have 3 burns for this mission to get goesu on its way, and this will be the first of those 3 burns.
TY boost back shutdown.
There we hear the 2 side boosters have boost back shutdown.
MECO.
And
Stage
now we're going to
separation
watch
confirmed.
live footage there. There you go of MECO. Again, the core
And back ignition.
booster separating from the second stage, and the MVAC engine on that second stage lighting up. You see that on the right side of your screen.
We're about 4 seconds from fairing deployment.
Fairing again is the two
All vehicles continue to
halves.
follow nominal trajectories. Bearing separation confirmed.
And there we have confirmation the fairing has deployed. The fairings are brand new fairings for the goesu mission, and they will fall back to Earth and be recovered by the recovery ship Doug. But SpaceX will look to reuse those fairings on a future flight, along with the side boosters. As we see there, they're coming back to Earth to land on landing zone 1 and 2. So things are progressing very well here. We are about a minute and 23 seconds from what we call the entry burn, where the plus Y and NY side boosters will fire up their engines to start slowing down the vehicle as it gets ready for landing.
Yeah, a lot to watch. Again, the left side of your screen, we are tracking the boosters that are coming back to the Cape here. On the right side of your screen, that is the MVAC engine on the second stage that continues to burn as it makes its way into the correct orbit to drop off goesu later today.
Stage 1 FTS is saved.
There we hear the autonomous flight termination system was saved as it returns back to Earth, making sure the vehicle is in a proper configuration for landing.
The second stage is currently taking goesu across the Atlantic towards southern Africa. And this is the first time, actually, a GOES satellite is launching on a Falcon Heavy. Only the second time NASA's Launch Services Program is using a Falcon Heavy.
Yeah, we launched our first Falcon Heavy with SpaceX back in October of 23 with the Psyche mission. And the side boosters actually that we used on the Psyche mission will be used for our future mission, Europa Clipper, this October. So brand new hardware today for goesu, and everything looks like it's performing very well. All the telemetry, everything looks nominal for the flight so far today.
Yeah, those who typically watch our launch broadcasts.
entry burn startup.
There we heard the call out for entry burn startup. The vehicles are slowing. You can imagine this as a brake on your car where it starts slowing the boosters back down very quickly as they
entry burn shut down.
And there we hear the shutdown as the boosters have slowed down. Next thing we will see is the landing burn
PY/NY FTS is saved.
at landing zone 1 and 2.
Beautiful
All
imagery
vehicles continue
again
to follow nominal trajectories.
from the ground as we track those boosters make their way back to the Cape. We saw some birds fly into the camera's view as well.
Everybody wants to see the landing
Exactly.
of the side boosters. As we said earlier, Megan, the landing will be exciting for a lot of people to see. Getting 2 side boosters coming back to landing zone 1 and 2, we will get those sonic booms. I know that you here in the MDC, we will get some.
NY transonic.
We will
Stage
get
2 FTS is saved.
we will get some loud shaking right here in the Mission Director Center. I know a lot of people right here in Brevard will be excited when they hear the sonic booms.
BY/NY landing burn.
Landing burns has
Stage
started
2 is
up.
the terminal guidance.
Wow, look at that. As it guides its way back down. Woo! Just heard the 2 sonic booms here in the room.
PY/NY landing light deploy.
Our monitors
that.
shaking
That
as we
looks
watch
amazing.
these 2
That is
boosters
just
land.
awesome to see the 2 side boosters choreograph their way down to landing zone 1 and 2.
PY/NY landing confirmed.
We have successful landing of the 2 side boosters. Everybody looks great on the landing zone 1 and 2 as MVAC continues its mission with this first burn. And there we heard the call out for SECO, which is SECO 1, second stage engine cutoff for this first burn. And things look very
Nominal
good. The
orbit
trajectory
insertion.
looks, we hear the call out there that nominal orbit insertion. Everything looks great on the second stage performance for this first burn, Megan.
Yeah, and what you're looking at now, everyone on your screen, is the trajectory for the second stage of the Falcon Heavy with goesu. So again, it's making its way across the Atlantic towards southern Africa. This was the first of 3 burns for the second stage. The second stage will now coast for about 18 minutes before reigniting for its second burn. And if you look at the bottom of your screen there, we have a progress bar full of our milestones that we're covering during this live launch broadcast. And SES-2, that is that second burn we are talking about that will happen in, again, about 18 minutes from now. So, Mick, as you said, so far, so good. Really exciting launch.
Very exciting launch, and we got through that weather, and goesu's on its way.
Yeah, very dramatic and appropriate weather
Absolutely.
as we and the launch team navigated that to see us lift off from the Space Coast at 5:26 p.m. Eastern Time. Again, we'll be with you for some of the milestones that you see on the bottom of your screen. But for now, let's turn it back to the host desk. Daryl and Alec, take it away.
All right, thank you very much. If you're just joining us, welcome live to the Kennedy Space Center in Florida, where we just saw goesu launch from right here at the Kennedy Space Center from Launch Complex 39A. I'm with Alec Krautman, who is from NOAA. I am with NASA, and this was a heck of a launch. We watched it out there together. It was interesting. I mean, that rumble and that roar. What did you think?
Oh, man, what a view. How did we get this weather window? It was outstanding. It was beautiful out there.
It was fascinating. You made the point to show me, like, look behind you. Here's these massive clouds that have accumulated behind us, far enough off to the west. But then as we look to the east, it was totally clear. Saw the thing go up the whole way.
Yeah, it's rocking and rolling in New Orlando, but we were all good here.
I tell you, you got to love Florida. Appreciate them holding off those storms long enough to get this thing going. Well, now the satellite is surviving the rigors of riding a rocket into space now, but we've got a long way to go, Alec. There's a lot more to do. We've got another short burn and then a long coast phase before we have separation. And then a NOAA team will start commissioning the satellite. So as we jump ahead in the timeline, what else does that involve?
Yeah, so these satellites will be operated out of our NOAA Satellite Operations Facility in Suitland, Maryland. And over the next several months, they'll be, first of all, letting the satellite do outgassing for a period of time, and then calibration and validating and checking out the instruments. And then we'll see first light with the various instruments later this fall.
All right, looking forward to that. And we'll keep chugging along here on our broadcast. In 2021, people living in southeast Louisiana were hit with catastrophic damage from Hurricane Ida. But there was fair warning of what was coming, thanks in part to high advanced resolution imagery from GOES satellites. Here's a closer look.
Hurricane Ida will long be remembered for its destructive, deadly path that stretched from Louisiana to the northeast. For meteorologists at NOAA's National Hurricane Center in Miami, NOAA's GOES-16 satellite provided the advanced high-resolution imagery for closely tracking Ida and developing accurate forecasts from start to finish.
We did see in the GOES imagery the development of that low-level center that allowed us to go ahead and call that a tropical cyclone.
But for Hurricane Ida, it was a case of there being more than meets the eye, literally. Within the eye of Ida, GOES-16's advanced baseline imager saw 4 mesovortices. A mesovortex is a small-scale rotation in the eye wall of a tropical cyclone, and it can be a telltale sign that a storm is getting better organized and intensifying.
Yeah, when we started to notice the mesovortices in the eye, that was during a period of time when we were starting to see some pretty dramatic inner core structural changes.
And with those changes within Ida's eye, scientists saw its wind speeds go up and its central pressure drop. Both of those changes can make a hurricane's winds and storm surge more destructive and deadly. But Ida still had a surprise after it made landfall. The mesovortices in its eye continued to spin around the eye even while it was over southern Louisiana.
It's quite unusual for us to be able to see the mesovortices, say, hours after landfall. And the reason is because after a storm comes ashore, it typically loses its fuel source. It loses its the warm ocean water, and that causes the storm to weaken.
But Ida's mesovortices were still visible over land because of what scientists call the brown ocean effect. Researchers have found that some tropical cyclones can maintain their strength long after landfall, or even strengthen over land by tapping into the abundant soil moisture below it.
We think that the reason that the storm remained strong in this case was due to the presence of that marshy land. So it was almost like the hurricane didn't know it was over land. It thought it was still over the warm ocean water.
Hurricane Ida will definitely be a storm for the history books, and its full impacts are still being tallied today. For future hurricanes that threaten the U.S. and elsewhere, NOAA satellites will be our eyes in the sky to help forecasters stay on top of these monster storms.
T plus 14 minutes. Everything's good with the spacecraft and rockets so far. Let's check in now with NASA leadership. Philip Hargrove is with NASA's Sandra Connolly.
Yes, thank you, Daryl. I'm here with the Deputy Associate Administrator for NASA's Science Mission Directorate. Thank you so much for being here, Sandra.
Thank you so much for having me.
Yeah, I mean, what a day, what a moment. What was the launch experience like?
You know, absolutely fabulous. Beautiful launch. I could not be more thrilled. I have to say, I'm privileged to have seen several launches. Gorgeous day, and I actually got to see those boosters land. Fabulous.
What a show. So beyond the launch itself, what's exciting about the goesu mission for you?
So goesu is so important. As you know, it's the fourth in a series of geostationary satellites that actually support our weather, whole weather forecasting system. And so they stare over the U.S. or over the actual whole Western Hemisphere and provide us really critical data as storms are forming and evolving so that we can be prepared in advance of, during, and actually support after storms occur. So it really is an important satellite system for us.
Awesome. Can you talk a little bit about this connection between NASA and NOAA and how that has developed over the years?
Yes. So we have had a partnership for 50 years with NOAA. We have been building these kind of spacecraft. We develop them, we launch them, we commission them, and then NOAA operates them. And it's to support both terrestrial and space weather. Space weather is basically the sun's sending energetic particles towards, well, it's throughout the solar system, but it's when it comes towards the Earth that it can sometimes impact our power grids and cause problems for us here on Earth. So it's important to study space weather as much as it is terrestrial weather.
Awesome. And can you tell us about what's next in this NASA-NOAA collaboration?
Yes. So again, we've had a long-term partnership, so we continue to plan for the future. So there is a GeoXO series that is going to be the GOES-R series follow-on. So we're very excited to be partnering with NOAA on that. But also NASA has, on the space weather side, we have a mission called IMAP that's launching in the springtime. And we have a rideshare mission called Space Weather Follow-On, which is a NOAA mission. So we're going to be advancing our work in space weather as much as terrestrial weather.
Awesome. Very exciting stuff. Thank you so much for being here. Glad you got to witness that in person. And yeah, thank you again.
Thank you. It's fabulous.
All right. I'll send it back to you all.
Thank you. And we've been talking, of course, about goesu and the mission as we continue to track the rocket and spacecraft there, T plus 17 minutes, the second stage, and goesu making their way through space, getting ready for another burn. Alec, we want to talk a little bit about hurricanes. You were a forecaster, meteorologist in the Gulf, right? Louisiana, spent a lot of time there. Let's talk about the most deadliest and most destructive aspect of a hurricane, and that's storm surge. How can goesu help with storm surge? Is that possible?
Yeah, the deadliest aspect of a hurricane, definitely storm surge, the water in general, storm surge and inland flooding. And so from GOES satellites, we monitor the strength and intensity of the storm as it comes to shore. And after landfall, we have a flood mapping capability with our ABI. This is an image from our polar satellites and from the geo satellites with the ABI, and it shows the general extent of inundation after a storm. You can see this from the Louisiana coast after Hurricane Laura, and it gives emergency managers an idea of where flooding is on the ground. And using only our polar satellites, we can downscale this imagery to about 30-meter resolution. So this image that we're looking at now is from the polar satellites, and it gives you a better idea of where water is still residual in communities. And so this is residual water from storm surge and water from flooding from heavy rains.
So this is a valuable tool, as you mentioned, for emergency managers after a storm, because you got to know where your flooding is. You got to know where the people who are potentially stranded from that kind of water need help.
And to deploy resources and to coordinate response.
All right, very good. So continuing talking about hurricanes a little bit, earlier in the show we talked about NOAA's forecast for this year, and it's going to be a super active one. 4 to 7 major hurricanes with 110 plus mile per hour winds forecast for this hurricane season. Very important to the folks here in Florida and all the way up the eastern seaboard, as well as the Gulf. Why so many this year?
That's right. We're really seeing exceptionally warm sea surface temperatures across the Atlantic Basin, the Caribbean, into the Gulf, and that's the main driver. We're also seeing weaker wind shear aloft. That would be a favorable environment for these storms to take off.
Right, and so when it comes to planning, it's really important that people have a plan. I think it's probably, every year we hear it, start a plan now. Most people, I think, or many people, I should say, probably say, I'll worry about that when I hear that's a storm coming. What are your thoughts?
Yeah, an active season forecast is a helpful reminder to revisit your plans every year, right? It really just takes one storm to impact your community, and so it could even be a light season, and if you get hit by a hurricane, then it's a big one for you, right? We had one of our Hurricane Hunter aircraft with us at Kennedy earlier today. So with our satellite imagery from GOES, the Hurricane Hunter aircraft, we're ready at NOAA for hurricane season. So we encourage everyone along the coast to do the same.
Alex been doing a great job answering my questions and showing off the instruments of GOES, but also throughout the show, we've been asking you to submit your questions on #AskNASA from the social media. So let's take a few more questions now, if you're good with that, Alec, and let's go ahead and start popping those up. We have Space Gamer on X asks, will there be any more launches for the GOES program after goesu, or is this the end of this part of the GOES program?
This is the end of the GOES series, and so next up will be GeoXO. So our future geostationary weather satellites will be this GeoXO series, with the first one scheduled to launch in 2032.
That's a ways from now, but the technology on GeoXO, how different is it going to be from goesu?
Even more high resolution for the current instruments. We'll have another imager. We'll have the lightning mapper. We're also adding new instruments, a hyperspectral sounder, an ocean color instrument, an atmospheric composition instrument. And that'll give us more information about our environment and our climate.
All right, another question. Let's go to Avincia. She asks, why are the satellites renamed? Why are the satellites renamed once they reach orbit?
That's right. So on the ground, we go by the letters. So this one was goesu. Once it reaches geostationary orbit, it'll be renamed goes-19. It's indicative of the successful mission once it makes it. This is a risky process, and so it gets a new name once it achieves that milestone. And then we have the operational goes east and goes west positions.
All right, very good. Thank you, Alec. Let's send it back now to Philip Hargrove, who was on a packed balcony during launch with a member of NOAA's leadership. Philip.
Thanks, Daryl. Yes, I'm here joined by the director of NOAA's Office of Space Weather Observations, El-Sayed Talat. Thank you so much for being here.
I'm very pleased to be here. Very excited.
Awesome. Yeah. How was the launch? Tell me what your experience was like.
It was fantastic. It was picture perfect. It was beautiful. And the sound was just amazing.
Yeah, really, really was. So we've heard a bit about this compact coronagraph. Can you tell us a bit more about that instrument and why it's important that that's on goesu?
So the compact coronagraph, or CCOR-1, is the first operational coronagraph that we're ever going to fly in space. And it's a advanced solar telescope that blocks the disk of the sun so that we can measure the outer atmosphere of the sun, the solar corona. And it's very important to measure that because that's where space weather, extreme space weather events originate. These large explosions off the sun called coronal mass ejections that can send billions of tons of matter hurtling towards Earth at millions of miles per hour.
Right, so it kind of creates its own solar eclipse. I think that's what you told me earlier.
Yes,
right?
Basically this telescope will be able to take a solar eclipse and send it down to the forecasters every 30 minutes, within 30 minutes, so sooner than that. And it'll be the continuous operations of having a solar eclipse basically within 30 minutes continuously.
And can you tell me about how this instrument works with the other instruments on board?
So what this instrument does, it allows us what our long-term forecasting in space weather. So 1 to 4 days after we see an explosion off the sun, we measure the characteristics of these explosions and put it into our models that propagate it towards Earth and see if it's going to come towards Earth, and then estimate how big the impact is going to be. And we really need to know that because that's important to protecting our technological infrastructures. These solar storms can affect the power grids, civil aviation, and other satellite operations, as well as communications and navigations. And this works in tandem with the other solar instruments on board that measure the solar and EUV, X-ray and EUV irradiance, and image the sun. And then the imagery of the sun gives us the context imagery of the sun that is basically like looking at the Atlantic basin for tropical cyclones as they develop, and then they might develop into hurricanes. We look at the sun with a solar ultraviolet imager to see if these regions of activity, which are centered around sunspots, if they're going to develop and produce flares and explosions, these coronal mass ejections. And we measure those effects with the irradiance measurements and the particle instruments that we have on the GO satellites.
Very interesting. And then what's next for NOAA with regards to space weather prediction?
So it's a very exciting time for space weather because we're developing, enhancing our capabilities. We are going to fly next year, in 2025, the Space Weather Follow-on L1 mission that is going to be an upstream buoy for measuring the solar wind and incoming solar effects 1 million miles upstream of Earth towards the sun.
Very exciting stuff. Thank you so much for being here, and I'll toss it back to you, Megan.
Philip, Meg and I, again, are back here at the Mission Director Center at Hangar AE on Cape Canaveral Space Force Station, and we continue to monitor the teams as they continue the journey to deliver goesu to its correct orbit around the Earth.
Yeah, things are going very well. That first burn, all the telemetry looked very good. Nominal. The vehicle's in a coast phase right now. Our next step coming up will be SES-2, that second burn, which we should be hearing here in about 20-25 seconds. Things are progressing well, and goesu looks very good.
Mm-hmm. Again, the milestone bar at the bottom of your screen is where we are in the milestones to getting goesu into its correct orbit. SES-2 is that second burn that we're talking about, and we're tracking that for 26 minutes and 19 seconds. So 5 seconds from now. All right, and there we go. We see the MVAC engine on the Falcon Heavy second stage lighting up. This is the second of 3 burns for this engine. This burn is going to last about 1 minute and 27 seconds.
Things are going very well with the launch vehicle as they are on this trajectory that Mark Hammett's talked about, raising that orbit up to where we need to get going for that coast phase to head out to geotransfer. So things are looking very well, and all the telemetry on second stage is performing good. Our MVAC is performing very well, and telemetry looks like we are heading in the right direction, and the vehicle's performing nominal.
The image that you're seeing right there, an animation, again, of where we are, the trajectory that we have been keeping an eye on, and as you said, that we had an interview about earlier in the broadcast.
Yep, we are about 20 seconds from SECO 2, and the vehicle is progressing in a good velocity, stage 2 velocity, and putting goesu where it needs to be and making that adjustment in the trajectory that Philip and Mark talked about. And things look good as we're getting ready for MVAC shutdown here in about 5 seconds. Things still progressing well. And there we see MVAC shutdown, and we are beginning this coast phase. Megan, things look good on the vehicle as we are watching the telemetry screens here from SpaceX. The vehicle performed very well during that burn. And there we heard the call out for a nominal transfer orbit, and we get ready for this long coast before our third burn.
Absolutely, a long coast phase. We're looking at a coast phase of about 3 hours and 53 minutes. Again, this is a very well choreographed to the second trajectory that gets us to that geostationary transfer orbit that you're talking about. LSP's mission is to deliver goesu to that geostationary transfer orbit, and while it's there, they're going to do some checkouts of the satellite, and then once operational in geostationary orbit, that is where goesu becomes goes east, and we'll keep a continuous watch over the Western Hemisphere.
Yeah, as we get goesu on its way today, things progressing forward. As Alex said, very exciting to see the liftoff of the Falcon Heavy with goesu. Second stage is performing very well on that, and as we can see on the screen there, that stage 2 is coasting where it needs to get to, that normal geotransfer orbit insertion that we've heard about from Mark and Philip, and things are going to progress very well as the vehicle orients itself and gets goesu oriented on its way for that third burn, which will be a very important burn to finalize the mission to get ready for deployment. And part of that would be that the Falcon Heavy performed so well today that will that extra performance we had will give goesu a little bit of extra life on orbit, because they don't have to use as much spacecraft fuel to get to geostationary. So vehicle performance looked very good today.
Yeah, goesu the GOES satellites are designed to have 15 years of life, but because we are saving propellant on the spacecraft, because Falcon Heavy is delivering it farther towards its orbit, we are looking at a 20 plus
Almost
year
20
life.
years,
Yep. So again, just any other check of the spacecraft before we sign off for a little bit for this coast phase, Mick?
Nope, everything looks good on the spacecraft side. They are operating on batteries. As Mark said, they are on the right trajectory with the sun in the right position to get ready for deployment. And after deployment, they'll get some of their solar arrays out, partial solar array deployment, to be able to charge those batteries and get going, and then begin their work in the next few weeks to get to geostationary.
All right, so again, a coast phase of just under 4 hours. Mick and I are going to pop in at the top of every hour, so 7 and 8 o'clock p.m. Eastern Time, to give you some quick updates about how everything's going. But for now, let's toss it back to Philip.
Thanks, Megan. Yes, I'm here with the NOAA administrator, Rick Spinrad. Thank you so much for being here with me.
I'm delighted to be here for this wonderful occasion.
Awesome. Yeah, tell me about the occasion. What was your experience like?
So this was obviously an awesome experience, seeing the launch. I've got to say that it's a seminal event. It happens over just a few minutes, but you realize there's years and years and thousands of hours of contributions from everybody, and see it come together so beautifully, so well done, so comprehensively is awesome in the literal sense of the word.
Absolutely. Thank you for that perspective. Can you tell me a bit about why this satellite is important to the nation?
So for us at NOAA, we feel that our main responsibility is providing environmental intelligence about the Earth so that people can make decisions about economics, about safety, about protection of property. This satellite is a critical component in our understanding what's happening in the Earth, the ability to watch it, see storms forming, see smoke moving, see all the changes in the patterns of the currents in the oceans, and use that then to provide decision support. All of this is contributing to what we hope will be a climate-ready nation. We can only be climate-ready and be prepared for the impacts of change and devastating weather and climate events if we've got the information upon which we can make decisions.
Right. And can you talk about how NOAA collaborates with NASA to get that information and achieve those goals?
We've been working with NASA for decades. It's a wonderful collaboration. In fact, if you look at the people at the launch here, many of them worked in both agencies for many years. And basically, to define the sort of swim lanes of responsibility, NASA is the acquisition agent. They have responsibility for making sure the satellite and the sensors are built according to the specifications. NASA also obviously provides the launch services that we saw here today. NOAA is the operator and manager, so when the system becomes operational, we also provide the funding for the acquisition. But by this spring, when goesu becomes GOES-19, it will be an operational satellite. That will be our responsibility to be monitoring the health and using the data 24/7, 365.
Awesome. And can you tell me about what you're looking forward to with this collaboration?
The continuation and continue to build the capabilities. NASA brings some incredible innovation to the table that we're going to build into the next generation of satellites. GeoXO is the continuation of the GOES-R series. We'll be launching GeoXO in about 2032, and between now and 2032, I expect nothing more than the continued great collaboration and innovation we've seen between NASA and NOAA over the last several decades.
Awesome. Thank you so much. That's some exciting stuff, so I appreciate you telling me all about it, and thank you for being here.
Thank you. My pleasure.
All right, back to you.
Thank you, Philip and Rick. And that was a nice burn that we just saw there. Still good things happening.
Nominal, on the way to orbit.
Yeah.
Sounds good to me.
Stoked about that. All right. So now goesu will coast for almost 4 hours before spacecraft separation. Alec and I are going to step aside during that time, but of course, we're going to be keeping track on what's happening. There'll be a live tracking animation of the journey the entire time. And of course, we'll have brief updates on goesu from Megan and Mick on the hour. But before we break, after the successful launch of a weather satellite, well, we want to celebrate a little bit by showing